Hi guys, welcome again to another lesson with me, yours truly, Mr. Roundy. Today we're going to be working on our lesson about factoring linear expressions. Now, factoring linear expressions, we're going to start out with one vocab word, and that is monomial. Now, rather than write out a word definition, I figured I would just give you an example of what a monomial is. A monomial is a number, like 4, or a variable like y, or the combination of a number and variable together, or the product of a number and variable like 4 times y. These are all examples of monomials. Monomials do not have any addition or subtraction signs in them. So for example, if I had something like 4x plus 2, this is not a monomial. It's made up of two monomials. The 4x is a monomial and the 2 is a monomial, but the whole thing together is not a monomial. Okay, so hopefully you've got a pretty good understanding of what a monomial is. Now today's lesson says that we're going to be factoring linear expressions. Now, linear expressions are expressions that we've been dealing with here in class, like 4x plus 2. Plus 5x, and we've been combining the like terms to create a new simplified expression. Now, factoring is something that we've actually done in the past. For example, in the past we've had numbers like 10 and 20, and we've asked what is their greatest common factor, or what are the factors of 10 and 20. So I would list all the numbers that can be multiplied to make 10. So we've got 2, we've got 5, we've got 10. Oh, and I forgot 1 as well. These are all numbers that can be multiplied to make 10, so they are factors of 10. 20 would have numbers like 1, 2, 4, 5, 10, and 20 are all factors of 20. Now, just like we've done here where we've written down the factors of 10 and 20, you can factor monomials as well. Now, if we were looking for the greatest common factor of these two numbers that I just looked at, we would see that the largest number that they both have in common is 10. So their greatest common factor would be 10 for the numbers 10 and 20. Well, in today's lesson, you're going to have to be able to factor monomials. So for example, let's say I've got the monomials 4x, and I've got another one over here, 12x. These are both monomials. They don't have any plus signs or minus signs. They're just 4 times x and 12 times x. Now, to factor a monomial is actually quite simple. All I've got to do is look at the numbers. The number 4 has these factors, 1, 2, and 4. These are the numbers that can be multiplied to make 4. 12 has the following factors, 1, 2, 3, 4, 6, and 12. Now, the largest factor that both of these have in common is 4. So if I asked for the greatest common factor of these two monomials, it would be 4, but that wouldn't be all of it. The thing that they also have in common is both of these monomials have an x. So the greatest common factor of the two monomials would be 4x, because 4 is their greatest factor number-wise, and they also have the common factor of x together. So 4x is our greatest common factor for these two monomials. Let's try factoring another pair of monomials. Here we have the number 12 and we have the monomial 28c. These are both monomials. And so I'm going to start by listing my factors. 12 has the factors 1, 2, 3, 4, 6, and 12. 28 has the factors 1, 2, let's see, 4, not 5, not 6, 7 does. 8, no. 9, no. 10, no. 12, no. 13, no. 14, yes. And I think 28. So here we've got our factors of both numbers. Now let's see which one we have that's the largest one that they both have in common. Well, it looks like again we have 4 is the largest number that we have in common for both of these. So if I was asking for the greatest common factor, well, we'd have 4. Now notice this one doesn't have a C and this one does. So since one does and one doesn't, that's not a common factor that they have. So my greatest common factor for these two monomials is just 4. Not 4C, but 4, because this one has no C and this one does. So they don't match, so they don't have that particular factor in common. So 4 is our greatest common factor. Let's factor one more set of monomials. Here I've got 42 times m times n. These are monomials. There's no plus or minus signs in here, so it's a monomial. I also have 14 times n times n. So let's start with working the numbers. I've got 1, 2, 3, let's see, no, 4 won't, 5 won't, 6, yes, 6 does, and 7 does, 8 doesn't, 9 doesn't, 10 doesn't, 11, 12, 13, no, 14, yes, and let's see, 21 and 42 are my factors. Oh, sorry, cut off a little bit of my bottom number. There we go. And now we've got 14. Well, we've got 1 is a factor, 2 is a factor, 3 is not, 4 is not, 5 is not, 6 is not, 7, yes, and 14. So first I'm going to find the number that's their greatest common factor. Well, I see here that 14 and 14 are the biggest one that they have in common. So let's see, GCF, we know it's 14. Now I look at their variables and see what variables they have that match. I notice that this one's got an M, so does this one. So that one would be a common factor. And this one has an N, so does this one. So that's a common factor. So the greatest common factor for these two monomials is 14 times M times N. And that's my greatest common factor for these two monomials. Let's take a look at why we need to understand this information about greatest common factors of monomials. It's going to help us factor linear expressions. Now here we've got a linear expression, and this linear expression, 8x plus 4y, would represent a line on a graph. Now we don't have to worry about the line or the graph right now, we just need to worry about the expression. This is an algebraic expression because it's got variables, and what we're going to do is we're going to factor it. And the way I like to think about factoring is I like to think of it as reverse distributive property. It's like we're going to do distributive property, but backwards. So what we're going to do is treat these two pieces like they are monomials. So we've got the monomial 8x and we've got the monomial 4y. And I'm going to factor them. So I've got 1, 2, 4, and 8, and 1, 2, and 4. So the greatest factor that they have in common is 4. Now notice that their variables don't match, so the factor that they have in common is 4. So I'm going to write this up off to the side so we remember it and erase my work. So what I'm going to do now is I'm going to try and work my problem in reverse distributive property order. So what I'm going to do is set up my problem like it was a distributive property problem where it has parentheses. And this 4 that I just got is going to go on the outside of my parentheses. And I'm going to ask myself, 4 times what would get me 8? Well, 4 times 2 would get me 8. So I'm going to put that 2 here in the parentheses like it was going to be a distributive property problem. And I need to have 8x. So I'm going to have to do 4 times 2x to get 8x. Now I'm going to need a plus sign. So I put my plus sign in and I say 4 times what got me 4? Well, 4 times 1. And I need it to have a y, so I'm going to add a y with it down here. Now I can check if I factored this correctly by doing distributive property, because we said factoring is kind of like backwards distributive property. 4 times 2 gets me 8x, and 4 times 1y gets me 4y. So yes, I've done my factoring correctly, and when I'm done factoring, I have 4 times 2x plus 1y. Now, I don't need to write a 1 in front of a variable. That's just not done in algebra because 1 times the variable is going to get me 1. That's the multiplicative identity. So this would be my answer if I was asked to factor the expression 8x plus 4y. Here's another example. I have 3x plus 9. 3x plus 9, I'm going to treat like two monomials, 3x and 9. And if I list the factors of 3, I get 1 and 3. If I list the factors of 9, I get 1, 3, and 9. So my greatest common factor between the two is 3. This one has an x, this one doesn't, so I can't factor out an x. And so I'm left with the greatest common factor of 3. I'm going to erase my work now and work on factoring my expression. So I've got a 3, and I'm going to put my parentheses. And now to factor out, I factored out a 3. Now 3 times what got me 3x? Well, 3 times x got me 3x. And 3 times what got me 9? Well, 3 times 3 got me 9, and there's a plus sign between them, so I put my plus sign here, and here is my factored expression. Here's one more example. I've got 4x minus 28. So this is a linear expression, or just think of it as an algebraic expression, and we're going to factor it. So we're going to break it into its two monomials, 4x and 28. I don't really worry about the sign between them. I take care of that at the end. So I've got 4x, that gets me 1, 2, and 4 are my factors. And 28, I've got 1, 2, 4, 7, 14, and 28. And the largest one I have that both of them have is 4. Neither one, or sorry, I should say one has an x, one doesn't, so I don't factor out an x. All I can factor out is the 4. Again, I'm going to write my 4 and put in my parentheses. Now 4 times what would get me 4x? Well, 4 times x got me 4x. And 4 times what would get me 28? Well, 4 times 7 gets me 28. The sign between them was minus, so I keep a minus sign right here, and here is my factored expression. This is one final example for us to look at. We have 12x plus 7y. Now, let's start by working to factor this particular expression. I've got 12x as one monomial, and I've got 7y as my other monomial. If I factor these two, I'm going to say, well, 12's got 1, 2, 3, 4, 6, and 12 as factors. 7's got 1 and 7. Now, if I look at these two lists, I've got 1, no. Nothing matches. I look at their variables, x and y. Nothing matches. So, what do? On a problem like this, where there's no factors in common, both in the variables and the numbers, then this type of problem can't be factored. And that is the answer that we would give. We would say, nope, this one can't be factored because it has no common factors within my two monomials. So I would say can't be factored because no numbers factors are in common and the variable factors aren't in common. So there's nothing I can factor out. So I'd say can't be factored. Well, that's the end of our lesson on factoring expressions. I hope you had a good time. Thanks for watching.